morning, everyone, and welcome to today's Geoscience Australia Wednesday seminar. My name's Narelle Newman, and I'm really pleased to be able to introduce the seminar today on behalf of our Chief Scientist, Clinton Foster, who can't be here. Today's seminar is a really exciting one because today we hear presentations from our 9 new graduates at Geoscience Australia. The graduate program here at Geoscience Australia has been running since 2001 and is a key part of the agency's long-term staffing and science direction. It's a 12-month program, and during this time the applicants or the graduates are able to undertake 3 projects to really explore both the breadth and the diversity of work that's undertaken at Geoscience Australia. And the program really positions them well for an exciting and diverse career at Geoscience Australia. So today is a chance to meet the 9 graduates as part of this year's program and to find out a little bit about their research background as well as their interests. So as I invite the first speaker, Adam, to the stage, please join me in welcoming all of the Geoscience Australia graduates for 2015.
It's okay. That's all right. Good morning, everyone. As you can see from this rather dull slide, my name is Adam and I'm one of the grads for this year. Now, because it's so dull, I thought I'd start on a better slide. So this is me, and as you can see, I'm trying out to be Vietnam's next top model. And I think that says a lot about me. So you're going to hear a lot about where people are from and all that sort of stuff, and that's a very hard thing for me to answer and talk about, seeing as I come from a military family and have lived in a lot of places. So I came up with this little map with my happy face showing everywhere that I've lived over the years and where I've grown up. Lots of areas around Australia, and lived in Penang in Malaysia for a couple of years as well, which was great. But there is only one place I really consider home, and that is Canberra. I spent quite a few years living here as a kid, and as you can see, I attended Marist College, and I've been told that I'm fairly standard of the graduates of that establishment, for those who are familiar with Marist. But while I was here, I enjoyed getting into a lot of things in the outdoors and lots of car clubs and all of that sort of stuff as well, as is typical of all of us, I think. But it has an end, and I actually moved to Adelaide to study, where I started a degree in marine biology. I quickly found out that marine biology wasn't entirely for me, as enjoyable as it was and as interesting as it was. I just enjoyed geology a bit too much. It was fascinating looking at all the rocks and the earth, and more than anything, enjoying all the fun that happens on field trips. So I quickly swapped across to that and soon found myself with a geology and geophysics degree. I got trapped then into doing honours as well, because I thought, why not? Followed my interest and went into the Australian School of Petroleum, where I graduated in 2011 and had my typical hat-throwing moment. I think I lost that hat actually, went over the fence somewhere and never got it back. But I then made either the biggest mistake of my life or the best choice of my life, whichever way you want to think about. And in the after party of that, I tried on someone's hat who had just finished a PhD and thought, this is awesome. This is the best hat I've ever seen in my life, and I want one. So I started a PhD again at the School of Petroleum, looking at natural fractures and methods of improving methods of remote sensing those on a project entitled the Australian Structural Permeability Map. Which, shameless plug here, I will be talking about in a research resource division talk mid-April, so please come along to that if you're interested. But as you all know, you have to hope your way through a PhD. Hold on, PhDs do end, or so I'm told. I'm not quite there yet, but hopefully we'll get there. And as fun as everything was in the research area of my PhD, I got to do a lot of other things as well, which was great. I got to do a lot of travelling for international conferences and courses all throughout Europe, Australia, America during the middle of winter, so it's freezing cold. And I got to indulge in a few other things I enjoy, such as trying fancy beers and lots of local foods, which was always fantastic. And one of the other great opportunities offered by my PhD, which was one I probably missed the most since finishing up and coming over to GA to work, is the chance to demonstrate for the undergrad students on various field trips. So as you can see, I got around that a fair bit, and spent lots of time in the field with great people and teaching excellent students. And one of the things many of you are probably familiar with is as you teach people, you also learn from them yourselves. And one of the things I picked up from my students, especially among recent years, is the art of the selfie. So if you're ever in the field with me and you see me just stopped at some sort of landmark with a camera out, don't be scared, I'm just taking a photo. But that's all there is to me. As any of you who have met me so far will be very well aware, I am incredibly into sports, particularly my cricket. So last night was a great night for me with the New Zealand game, but I've been around to quite a few games, and the World Cup this year has been a fantastic opportunity. But I also partake in a bunch of other sports, notably soccer and track cycling. So I was very depressed to find out that the velodrome has recently closed in Canberra. Now I'm at GA and I've started on my first rotation. I'm looking at controls and hydraulic fracture generation in unconventional hydrocarbon reservoirs, so it's very much up my alley and sort of a continuation of the sort of thing I was studying for my PhD. And in the future, for my next rotations, I'd really like to look at applying my skills in other divisions, which I'm less familiar with, particularly looking at something to do with possibly hazards or groundwater impacts of natural fracturing, as it would expand my understanding of a topic that I already feel quite familiar with. So that's really it for me. So I'd like to pass on to the next speaker, who is also one of our grads, understandably, our man Ben. So please welcome him to the stage.
Thank you for that introduction, Adam, and yep, that's me. So my name's Ben. I grew up in Wagga. I've always been very keen on science and on technology. Now, when I was a kid, I spent a lot of time watching documentaries and reading encyclopedias in front of the fire and programming computers to generate fractals and things like that. I had a relative who tried to buy me the most difficult puzzle possible to solve, and this was it. And indeed, I couldn't figure it out, so I wrote a computer program to rotate it in 3 dimensions until it brute forced all the possibilities and found me all of the solutions. After high school, I went to the Australian National University. Initially, I studied biology, chemistry, mathematics and physics. I had the best marks in physics, so that's where I concentrated. I did my PhD in gravitational physics. So the foundation of general relativity, it's exactly the same mathematics as you use for working with maps over curved surfaces. So my project was developing tools for exploring new solutions of the Einstein field equations. So it's kind of a bit like making an ArcGIS software for 4 dimensions. Now, so this piece of software, the idea was that it encapsulated all of the mathematical details of frequently switching between coordinate systems, calculating geodesic lines over the curved background, all that sort of thing, and left you to just concentrate on the science. Now, being in Canberra, I found that one of the things I enjoyed most was finding all the different groups of people who were doing exciting things. So recently I took up rock climbing. I've been very happy to find that there's a whole bunch of other people at GA who are keen on getting up close to rocks as well. Well, this picture in the middle is practicing sea kayaking with a sail, and that was also a lot of fun until you capsize, and then it's quite difficult. As I was writing up my PhD, towards the end I was offered a temporary contract at Geoscience Australia. I worked on well log data in a geophysics sort of role, so sourcing old and recent well logs, geophysical logs, electric logs, and combining those to calibrate seismic surveys, so generating synthetics. Also helping to support the Schlumberger geoframe software and doing bulk loads between databases, between corporate and project databases, digging up discrepancies between different databases and sorting those out. After my contract ended, this was winter last year, I then decided to move up to Brisbane and start a bit of work in the neuroscience area at the University of Queensland. So for this project, I was working with data from about 30 different sites over the scalp of the human head, and using structural information, we had about 40 different hypotheses about what was going on inside people's brains to explain the dynamics that we were seeing. And so I was learning a bunch of techniques such as using Bayesian analysis to compare all these models of differing complexity to figure out which ones are fitting best, and then using machine learning techniques to analyse and classify the parameters that we were getting from the best fitting models. Now, as a science graduate at GA, my current rotation, I'm looking at the corals around Ball's Pyramid, which is near Lord Howe Island. Now, looking at this coral cover, one of the things we're interested in is whether this diversity, for example, whether it will act as a refuge when there are bleaching events at Lord Howe Island. Ball's Pyramid is interesting because it's the southernmost limit of coral reef development. For the future rotations, I have a lot of skills in mathematics and in scientific programming, so I'm hoping for opportunities to help to solve interesting and difficult problems. I would now like to introduce my esteemed colleague, Chris.
Thanks, Ben. As many of you will find out during this talk from my accent, I'm from the UK. Just to give you a bit of background where I'm from a county called Dorset, which is on the south coast of the UK. If any of you have been there or from that area and know how beautiful the scenery is and how spectacular the coastline is, and that got me really interested as a child in coastal morphology and physical geography. So I enrolled in the University of Bristol to do a degree in geology, and it was there on a field trip to Santorini, a Greek island in the Aegean, which is basically a large volcano that got me really interested in volcanic processes. Not only is it a spectacular place to go if you're a tourist, but also the whole island is a large volcanic, or the remains of volcanic eruption, which had a big impact on the civilizations in the Mediterranean. So after my undergrad and honours, things were getting a bit too real and I had to make some life decisions, so I put those off for a bit, 18 months or so, and did a bit of travelling and working. So I worked and snowboarded in the southern French Alps, and I did a bit of travelling in South America. I then reconnected with some of my lecturers from Bristol University, and they put me in touch with various people around the globe, various researchers, and that led me to applying and being accepted for a PhD at Monash University in Melbourne under the guidance of Ray Cass. So I was very lucky in my PhD project. It was on examining large volume eruptions with a case study in the Central Andes of South America in Argentina. Just to give you an idea of the scale of these eruptions, this is me standing on top of a 100-metre thick sequence of volcanic material. About 2 million years ago it erupted, and it's about 20 kilometres away from the source of the eruption. Although it looks like an amazing place to do fieldwork in terms of the weather, the blue sky and the sunshine, it was extremely cold. We were working at very high elevations, and it was extremely windy, so some of the cool rock outcrops were created there from the erosion of the wind. But I did get a chance to sit back and take in the spectacular scenery there. So some of the methods that I used and the skills that I acquired were stratigraphic logging, field mapping, and then analysing the various samples we took for geochemistry and also geochronology. So here's an example of some of the zircons we looked at using shrimp. And then I went through the life cycle of the PhD student until I presented my thesis to the powers that be. More recently, I was very lucky that just after I finished my PhD, a position opened up at Monash as a lecturer, a short-term lecturer. And so I had these grand images in my head of what lecturing would be like. I thought there'd be a lot of students paying their full attention to me as a lecturer. However, I found it was a bit more like this in the lecture theatre. But we all know most of the learning comes from prac classes and on field trips. So I try to get involved in as many of these as possible. I also had a chance to co-supervise, be a sort of an associate supervisor for a couple of honours and PhD students, and that's when my research interest sort of developed out into looking at more of the hazards associated with volcanic eruptions, their impact on society. And I got a chance to do a bit of outreach work, so dealing with high school students and prospective students at open days. For example, here's a volcano experiment which we're doing. And I think it encapsulates the different responses we have for these kind of things. Some people are excited and want to get close to the eruptions. Some people are scared, and some people want to get up close and taste what's going on. My interests outside of academia or work are a sport called Ultimate Frisbee. What is this sport, you might ask? Well, what it isn't is this. Although it's very spectacular, there's no canines involved. It's a team sport where it's self-refereed even at the highest levels, and you have to pass the frisbee or disc amongst your teammates until they catch it in an end zone. It is pretty athletic, and it is the next evolution of sports after American football and basketball. I also like to do the more usual things of cycling, trail running and hiking, all of which I found have infinite possibilities in and around Canberra. So that's my life distilled into a bit less than 5 minutes, hopefully. Currently, I'm working in the groundwater and environment section on a project which involves looking at national scale data sets in Australia to understand a bit more about groundwater surface water interactions. My other wish list, if you like, of rotations in the grad year are perhaps something in the community safety group, so looking at the impact in terms of science and on society of various earth hazards, and also perhaps applying my existing skills in geochronology and geochemistry and petrology in the mineral systems group. So if you've got any cool projects that you think I might be interested in or want to have a chat about setting something up, I'd be really happy to talk with you. Okay, I'll now pass you over to the capable hands of Eamon.
Thanks, Chris. So my name is Eamon, and yes, it begins with an E and an A. You can blame the Irish for that spelling. So I'm from Victoria, southeastern Melbourne, a place called Dandenong. And growing up in Melbourne, one of the key institutions of the city is this street directory, the Melways. And that got me really interested in maps and spatial stuff. Not just the Melways, but all sorts of maps. I also really enjoy sport, a whole range of team sports. I'm not very good at playing anything, but I do like my cricket. At school, I was pretty interested in science. I did find, though, that I wasn't really safe in the chemistry lab. I was involved in the Army Cadet Unit at school, and that got me interested in the outdoors. I've since found quite an interest in road gaining. I went to Monash University after school and wasn't really sure what I wanted to do. I got involved in a combined science and engineering degree. I ended up finding my interests with the outdoors and maps and all this kind of led me to looking at geosciences and civil engineering. I was also quite involved with some of the student club committees on campus, and that got me interested in how government operates. My project for my honours in geosciences was in hydrogeology. I was looking at groundwater surface water interactions at a very small scale, and I got to use computer modelling and fieldwork and geochemistry to combine to try and write up some 40-page something. After uni, I was actually unemployed for a whole year, so I'm actually excited to have a job. even more so that it's here. Combining my interests in the geology and all the science that's related with that and the outdoors nature of it, with the ability to serve the community in the public service, make my face at least that happy. I'm currently working with the groundwater peoples, looking at the mapping of Paleo Valley aquifers and applying geophysical and remote sensing data sets to try and understand the size and extent of our aquifers. One of the great benefits of the graduate program is that we get to experience a number of different rotations, and I find there's a number of areas within geosciences that maintain my interests over a broad number of areas. I would like to experience several rotations. Some of the things that interest me, but this is not an exhaustive list, are things like natural hazards, especially related to volcanoes or landslides, as well as understanding how stratigraphic classifications work to a greater extent. So I'm more than willing to listen to various ideas of where I might be able to progress in the future. I would like now to pass over to the Graduate Extraordinaire of Grant.
Morning everybody. Graduate Extraordinaire, I hope so, but it might be hard to live up to that. I'm just hoping not to bore the bejesus out of you today, to be honest. But so my background, I was born in New South Wales in a town called Bowen Mountain, which is in the Blue Mountains, but most recently I've called Montreal and Adelaide home. So I got interested in geology when I went to the Grand Canyon. I just was amazed that I could stand at 6,500 feet on the K-Bar limestone and realise that that was actually an ancient seafloor that's been uplifted with very little structural implication to that sort of level, and it just got me intrigued. So from that I decided I'd better go and learn something more about it. So like a few of my colleagues here, I'm also a graduate of the University of Adelaide, that proud institution, where I double majored in geology and chemistry. Couldn't get enough of Adelaide, so I decided to do honours there, and I did honours in Saudi Arabia. This is my first field area in Saudi Arabia. What you're looking at here is what is called the Jebel Taiz ophiolite. It's an ophiolitic melange, and for any of you people who haven't worked on melanges, the answer is don't. They are truly awful, especially from a structural perspective. Recently, really not part of my honours project, we recently went back to Saudi Arabia and started working on this area here. One of my colleagues had previously been here and had done some dating. This is the Antak Basin. While you can't see it here, it's actually chock full of ash beds. So when we first got here, we thought, great, we're going to be able to date this so precisely, but unfortunately they were very detrital-dominated ash beds, so the best thing that we got out of it, unfortunately, was a maximum depositional age, which was really unsatisfying. But we've recently gone back there and using some techniques on, so firstly laser ablating the zircons, getting rare earth patterns, getting titanium in zircon thermometry, we were able to pull out single populations. We then dated them with ID TIMS, and going from just the maximum depositional age, these cycles that you can see now, we've been able to constrain them to be 100,000 year cycles. So these look to be orbitally forced, so these look to be representing Milankovitch cycles. So just in the space of 3 years and applying a different method, it allowed us to go from a very crude age to a very precise age in this basin. After my honours, I went and did a PhD. My supervisors were Galen Halverson and Paul Hoffman, and if you know those people, it shouldn't be any surprise to you that my work revolved essentially around the snowball Earth hypothesis. This was done at McGill University in Montreal, and even though my PhD thesis was something like 300 pages, I was a bit deflated to find out that I could really discern it down to 4 pictures, and that is basically you take a large igneous province, you shove it into the tropics, the wet tropics, you weather it so much that you draw down CO2, you get yourself into a snowball Earth state, And as you come out of this snowball Earth state, one of the things that you definitely get is the reappearance of banded iron formations. So that is really my PhD in 4 pictures. Some of my PhD areas, this is by far the best photo I've ever taken in my life. This is 3 a.m. in the morning, so this is a typical midnight sun, so to speak, in the north slope of Arctic Alaska. These are the Kitty Cat Volcanics. These are part of the Franklin Large Igneous Province. So the sort of work that I did on here, we dated them. We used the same techniques actually that we used for in the Anzac Basin, as in we took a volcanoclastic which had lots of material in it. We could isolate single populations and date this to be 716 plus or minus 100,000 years. That's 716 million years. We did major element analysis, rare earth analysis, neodymium isotopes to understand how this worked. We then took this and we used neodymium isotopes on sediments to track it into the sedimentary pile. And here is another image of one of my field areas. This is the Totondak Iron Formation. So we've done probably the most fancy isotope system I've worked on here is iron isotopes. For any of you who haven't done iron isotopes and you're interested in redox processes, it is a fantastic system to use. Interesting sub-story that you can ask me later on. I was attacked by a bear this very night. Finally, as you see, all my colleagues have been talking about how they all want to work in natural hazards and do something with volcanoes. I get to do something right now. I've got the best project of all the lot, no offence. I'm doing non-seismic tsunami modelling from Heard of McDonald Islands. McDonald Islands last erupted in 2013, so it's quite active, and this is a great project. I'm happy to talk about any projects that anybody offers me. The only proviso I have is please make them cool, because that's what I want. And if it's geochemistry based, well, it'll be right up my alley. So on that note, Kelly, over to you.
Okay, well, I'd like to thank everybody for coming today to this opportunity that we've been given to introduce ourselves to the agency. But let's face it, this is actually a communications exercise, and it's an opportunity for us to present our CV to you. So to me, the communication of science is something that I'm really, really interested in, and something that I find very, very important. So to communicate, we need to find a common language. So the language that I'd like to use for you today is something that hopefully most people are familiar with, and that is of the marine sediment core. So we're going to look at the STREPEX stratigraphy. So the first thing that we need to do is to take our core, so we're going to get our multicorer, and we produce our first core. Now, to date the core, we're going to use a technique that I'm very familiar with, because I worked in the radiocarbon facility at the ANU for 6 years. So if we're using radiocarbon dating, what we can actually do is use the atmospheric bomb curve. And I'd just like to point out, for those of you familiar with the bomb curve, that I was actually born after the weapons peak, because the weapons peak occurred in 1963, and so I'm not actually 50 years old. But if we look back to the very beginning of this core, what we look at is the inspiration for me getting into science. So it was the David Attenboroughs, the Carl Sagans, the David Suzukis, and of course Jacques Cousteau, because I became a marine scientist. However, what I think is really important to note is, as we get further up the core into my early teens, I really wanted to become a marine scientist. But when I got into my late teens, all of these heroes that had once inspired me all of a sudden just became old men. And I didn't want to become an old man when I grew up. And so instead, losing my way just a little bit, I decided to take a gap. Now famously, this turned into a gap decade. Now you don't actually need to adjust your glasses. The gap decade is just as blurry to me as it is to you at the moment. But the really interesting part of this core comes when we start to look at the core top. So that's when I finally went back to university. So I started studying environmental science at RMIT University, and then I switched over to the ANU, where I really got my hands dirty with research. So if we look under the microscope here, what we're looking at is organisms that I have known and loved. So in the bottom left here, we actually have a lungfish scale. So I led the research group who were the first to radiocarbon date lungfish scales. So it was the first time that we could develop a non-destructive technique for aging these iconic species. By non-destructive, it means that we didn't actually need to dig out their ear bone. So we actually can produce age models, which are incredibly important for the management of this species. So after that, I really fell in love with the ocean. So this is my little lungfish here. We actually dated him to 70 years old, which was quite a bit older than we were originally expecting. But my real love came when I got out onto the open ocean. And so we have here in the top right, that is not a piece of orange for those algae lovers out there, and I'm sure there are many of you, like myself. That is a centric diatom, so a species of phytoplankton. And so we went out off the coast of New Zealand, and I was measuring silicon isotopes from these phytoplanktons as a way of being able to say something about the nutrient status of the ocean and how we could potentially use this proxy in a paleoceanographic context. I also found that my love of beanies really came into the fore because I got to both wear a large collection of my beanies but encouraged the bosun to wear something very similar. But the organism that perhaps I fell in love with the most was a certain biological oceanographer that I met out at sea, who I then married 2.5 years later. So after that foray into the ocean, rather than being on the top of the ocean, I went underneath to start looking at zooplankton instead. So that is a picture in the top left of a foraminifera, so a zooplankton which is really, really handy for paleoceanographic reconstructions again. So we used some skills that I had learnt during that blurry gap decade, and that was to be a scuba diver. So I worked as a scuba diver, a scuba instructor and a technical diver, and I used these skills on 2 different field campaigns, both in the Santa Catalina Island and in Puerto Rico, where we were culturing zooplankton. And then, because I'd become this expert on foraminifera, I actually got to go on a very high-profile expedition down to the Antarctic, where we were collecting zooplankton across the Southern Ocean. And there I also managed to fall in love with the media as well. And yes, that is another one of my excellent beanies that I did wear on national television. So what does all of these skills, where did that end up? Well, I started working on deep-sea corals for my PhD. So deep-sea corals is something that perhaps in a geoscience organisation we don't. A lot of people have said, well, how are you going to fit that into Geoscience Australia? Well, the techniques that I used were actually the same techniques that the organic geochemists use here. So I can work in both an environmental context as well as working in different areas of the agency, which I did for my PhD, where we reconstruct environments that we can't see. For example, if we were trying to look for petroleum. So where to now? Well, if we were to model what's going to happen to me next at GA, first of all, I'd get Ben to do the mathematical modelling because it's definitely not my foray. But doing a PhD is not just about being a subject matter expert. It's about all of those transferable skills that you also bring in. So during my time as a PhD student, I learnt to communicate both to a broader audience, doing a lot of outreach work, both with primary school, high school kids and undergraduate. I started up a research blog for our research school. I've written for popular science magazines. I've written for academic articles as well. And more recently, foray into some television work as well, doing some dinosaur documentaries, as well as working with on a camel expedition as well. And the big thing about the television work that I'm doing, it's not just about communicating science, but it's communicating the image of a scientist, which shouldn't just be a crusty old man. No offence to the crusty old man in the audience. I have also experienced in, oh sorry, or no offence to the young people who I've just offended in the audience. But also it's about project management. I've managed a large-scale project, largely on my own from start to finish. So for the moment, I'm now working in the community safety group in the natural hazards section as well, which I'm thoroughly enjoying because I get to sit at that interface between academic research, the promotion of science, as well as communicating science to the relevant stakeholders. So after this, well, that largely depends on who enjoyed this presentation, and I am available for discussion later on today. Moving right along, I'd like to introduce Ruslan.
Cheers, Kelly. So here's my life story in a nutshell. My journey to Geoscience Australia started when I was quite young. My father gave me some specimens when I was a little kid from Broken Hill and a few other mines around the place. And my brother was and remains a very avid fossicker and collector and hoarder of minerals. So he got me right excited and fired up for minerals and geology. But as I got a bit older and working life started up. I fell into social work, a story for another time I suppose, but I did a lot of youth work, one-on-one client work with young people, helping them to navigate their way through very challenging circumstances, and I did a lot of community development of work as well. During that time I got married, and my wonderful wife Catherine told me of her passions for material science and chemistry, which she at that time had not pursued, and she knew about my passions for geology. So together we motivated each other and took the plunge to go back to university and abandon our old careers, not permanently, but abandoned that. So we both went to the University of Wollongong. I studied a Bachelor of Science, majoring in geology, and my honours project looked at the evolution of copper porphyry deposits around central New South Wales. I won't talk about that too much now, but feel free to come to me later and ask me. So I thought I'd share with you now one of my big passions while I was at uni. Very early on I had a very strong desire to get some experience with industry, and found that university provided some opportunities, but not quite what I wanted. So I gathered a bunch of other like-minded students, and those who weren't like-minded I motivated to get a bit keen. And together with some student bodies we ran field trips to mine sites across New South Wales, as far out as Broken Hill. These are me under an open mine there and a lead zinc mine at Broken Hill, and on the big chair that's on the top of the tailings heap. And we ran field trips to other sites of archaeological significance, cultural significance, and other discipline-related things. We ran plenty of workshops where we had industry members come to our university and teach us how to do things that they would expect us to do in industry. Plenty of networking events in-house at the university and during our field trips. Loads of social activities and collaboration and cross-discipline work. And there was some stuff I was really proud of at university, and lots of good things came out of it. A couple of people got some jobs, there was a couple of research projects that came out of it, and it was all very exciting. So I, of course, enjoy geology in my personal time. These are just some terms that came to mind as I was thinking about what geology means to me in my personal life. And I like fossicking, and as I mentioned, for those who collect anything or collect specimens in particular of minerals, there is a fine line between collecting and hoarding, and I am certainly teetering on that edge at the moment. I enjoy getting involved in lapidary clubs. I hear there's a good one in Canberra, so I'm going to get involved there. My holidays tend to revolve around looking at the rocks rather than looking at the view. That's up in New Zealand there, and long drives with the wife. That's Bidgie Point. We spent about 4.5 hours driving, I think, just to catch it for about an hour before the sun went down. I like getting involved with my friend's fieldwork. This is a good mate, Dan. I dug a hole for him for his honours work, as you do. So if anyone has any field work going, I love to get involved and get my hands dirty, so that'd be good fun. And I found that my love of geology and the natural world has brought a lot of good friends into my life. So I've got a new life here at Geoscience Australia. The first rotation is with Evgeny in minerals, and I'm looking at modelling fluid flow within basins with a view of seeing how that might influence basin-related mineral systems such as lead, zinc, uranium, etc. I'm using Python programming language and the NCI to do this. Python is brand new to me. If anyone has any suggestions or can offer assistance, please get in touch with me. I'm loving it, but it is challenging. And I was also very fortunate to be able to go on fieldwork in Western Victoria just recently, just gotten back. Arms are still a bit tired. And digging more holes for Evgeny, so that was great. I'm trying to get involved. I've recently joined up with the diversity networks and women's networks, and I'd encourage more men to get involved. You could do a lot of good things if you do. And in general, I'm just keen to learn, contribute as much as I can, and enjoy the process now and into hopefully a very, very long future with GA. And this, by the way, are my rocks and minerals that I carved to Canberra. There's a pick for scale, it was very heavy, it was very delicate. Anyway, that's me. So I'd like to pass on to Steph, give her a warm welcome.
Right, so I'm an Adelaide girl, and I thought I'd start with some interesting facts about South Australia. We are just behind Hobart in the number of Test cricketers per capita. We also have the greatest number of Nobel laureates born in our state in Australia. Having said that, beer is cheap, and we have a lot of really quite lovely wine regions. So as a state, South Australia is quite athletic, we're reasonably clever, but we're also heavily intoxicated. It's a great state to be raised in and live in. After high school, I planned to defect across the border and go to the University of Melbourne, but life happened and I decided to stay in Adelaide. So I went to the University of Adelaide, where we have a beautiful campus here in the city. We have a family of ducks that are so popular, they have their own Facebook page with well over 1,500 fans. What started out as a law science degree with a microbiology major soon turned into scenes of this. I had some friends who were doing geology and they loved it, and peer pressure being what it is, I took it up as an elective. But just for a semester, just until microbiology gets interesting again. It didn't, and 7 years later here we are. What struck a chord with me about earth science is how it draws on so many different scientific disciplines. Everything from physics, hydrogeology, chemistry, it all contributes to our understanding of the world we live in and the world we stand on. I was hooked. So I completed honours in environmental geoscience. My project was a proof of concept, trying to find a link between the chemistry of eucalyptus leaves and subsurface salinity in floodplains along the Murray. If you're ever having trouble sleeping, I'm more than happy to send you a copy of the paper I wrote. A few months into mission took me to make some friends in the Galapagos Islands. I took a swim in Antarctica, but judging by my reaction to that, Canberra winters are going to be a bit of a struggle. I came back to Adelaide and knew that research is what I wanted to do. My thesis now is looking at the source and deposition of a unit called the Loxton Parilla Sands in the Murray Basin. I'm pulling apart the story of it to understand how and why it got there, why it's become so cemented with iron oxides, and could it have geochemical clues that make it relevant to the mineral exploration industry. So to answer some of these questions, I've turned to 3D geological modelling, hyperspectral reflectance mineralogy, microanalysis using the electron microprobe, and also my favourite, laser ablation. A big part of my PhD has actually been working within the Deep Exploration Technologies Cooperative Research Centre. It's given me some great opportunities to go over to Canada to attend the Prospectors and Developers Association Convention, PDAC, in Toronto, and also have a go at a researcher profile for YouTube. I think most of those views have come from my mum, so thanks Mum. The most important thing for me to come out of the DTCRC, however, has been that emphasis on relevance to industry and the application of science. That's what's motivated me through my PhD thesis and drove me to pursue a career here at Geoscience Australia. So now I'm here, and my first rotation is in the geochronology and stratigraphy section. What I'm looking at is taking what's inherently point data coming out of geochronological measurements out of the shrimp and trying to bring that into a GIS, mapping things that are inherently point data in a more spatial way that's perhaps more intuitive to geologists and mineral systems thinking. Where next at GA? Well, the mantle is the limit. I'd like to develop some more technical skills, get more experience with, say, geological modelling, some modelling on the NCI, isotope geochemistry, look at a few different applications of geochemistry, and really get out of my comfort zone while I can in this graduate year, and look at applications of my skills right across GA. So it's great to be here, and I'm looking forward to getting to know a lot of you and working with you over the years. And on that, I'll pass you over to Wendy.
Good morning. My name's Wendy. It's a great honour to be here, both here today and here at Geoscience Australia, and apparently this is my journey to GA. Oops. I was born overseas in Egypt while my parents were travelling, and I spent the next 5 years in Germany and travelling around Europe. I don't remember any of this, probably very formative, but at 5 we returned to Australia and took up life on the outer suburbs of Sydney. In an area that was bordered on the bush and was largely consisted of reclaimed orchards. I was a rebellious teenager, though I don't think anyone actually noticed. I didn't smoke. I was the only smoker and only non-smoker in a smoking household, and I listened to a completely different radio station to everybody I knew. But when I finished high school, I went off to my dad's old university, Sydney Uni, and took up a science degree. But I got restless there. So after a year, I transferred to an arts degree at Macquarie University and studied linguistics and anthropology while working in an Alzheimer's unit for people who were suffering from Alzheimer's and dementia. A couple of years on, I knocked on the door of one of my the professors at my university and convinced her somehow that she needed a research assistant. So then I got to spend a few years working on a project to create an archive of Australian written and spoken English, and spent some time in Central Australia on field trips studying Aboriginal English at both Alice Springs and in the remote Walpura community of Yuendumu. But eventually I got restless again and headed down to Tasmania from Sydney, and after a couple of years found myself a single parent with 2 children and a dog. When my second child was 2, I had time to pause and think about what I wanted to be when I grew up. Now, there wasn't a lot of call for linguists in Tasmania, so I decided to go back to university and study science. It's where I began, and it felt like the closing of a circle. So I went off and spent summer studying maths to prove that even though I was a linguist, I was a valid candidate for a science degree. And I enrolled at the end of that and discovered when my son was 7 and my daughter was 2 that all first and second year science pracs ran from 3 till 6 in the evening, except maths. So I enrolled in maths and then looked around at what to do next, and ended up enrolling in KXT 101, Programming and Problem Solving. Now, looking back, I have no idea how I had the courage to do that subject. I had very limited experience with computers. I had no idea about programming. I was way outside the demographic, both in terms of age and gender, and I was invisible. Nobody spoke to me for almost 6 months. But I loved it. As soon as I found out that the stuff that happens on the screen is controlled by words, I knew I was in the right place. So I've lost my place on that note. So I thought I was going to do science, but in actual fact I was just doing more linguistics. So I studied part-time there, and then when my daughter started school, I began working at a business called Technology Services Group in the telecommunications area. And I discovered that as much as I loved programming, my real strength lay in my desire to get to the heart of problems and find innovative solutions to them. Solutions that gave people what they actually needed, and solutions that came from really paying attention, understanding what was going on underneath what people were presenting. And then I worked for a while as a consultant in quality assurance at RXP Services. And that confirmed to me that being a linguist with a technical background was a really useful thing. And it also gave me a name for what I wanted to do, which is business analyst. Now, when I did this talk briefly in a practice session, everyone said to me, but we still don't know what you do. So I have a definition. What does a business analyst do? Fundamentally, a business analyst enables a business to evolve and mature and respond to the changing environment through the use of skills such as requirement solicitation, process mapping, workflow mapping, solutions architecture and so on. And a core outcome of a business analysis is a clear articulation of a problem, the real problem or opportunity that underlies the issue presented, and that's how a business analysis enables a great solution or innovation to be developed. So when I finished my degree and began applying for graduate programs, I knew what I wanted to do. I just needed to find somewhere that would both let me do it and teach me to do it. So here I am, not a scientist, but a graduate business analyst. So my first rotation here is at ICTIS, looking into the service management tool upgrade, which is really interesting and has implications for the provision of IT services across the whole of GA. And I have to say it's very gratifying to be involved with a team that is so committed to providing and improving ICT services across GA. For future rotations, I'm interested in opportunities to practice and apply the skills of a business analyst anywhere that their innovations and problem solving would be useful. Thank you.
It's really impressive, a great diverse group of skill sets, and I think we all look forward to working with you throughout the year. So that's the end of today's seminar. I really encourage you to come and chat to all of the graduates once we close the session today. But before we thank them all again for their presentations, I'd just like to remind you about next week's seminar, which will actually be a DGAL seminar. That's one of our distinguished Geoscience Australia lecturers. It'll be a presentation by Dr. Adam Lewis on the Geoscience Australia Data Cube and its applications both domestically and internationally. So I encourage you all to attend next week. And now I'd like to thank again the graduates for their presentations today.